Hello everyone, it's AI with Chucky, and welcome back to the channel. Today we are looking at the new kid on the block when it comes to zero-shot voice cloning and text-to-speech, LongCat-AudioDiT in this tutorial. We are going to dive deep into how you can run this powerful audio model completely for free using Google Colab. I have actually packaged this into a professional studio setup within a simple Python notebook. I custom-built several features into it that are not natively part of the base model, making it much easier and way more powerful for you to use. It allows you to perform zero-shot text-to-speech, voice-to-voice cloning, cross-lingual dubbing, and even generate multi-speaker podcasts. Plus, we will be leveraging the free tier of Google Colab, which grants us all the compute power we need. To kick things off, you will need to download the LongCat Colab notebook file from the video description right to your local machine. Next, open your web browser and navigate over to Google Colab. On the Welcome screen, or by opening a new notebook prompt, simply select the Upload tab. Click to browse your storage, locate the LongCat-AudioDiT notebook file you just downloaded, and open it. It will only take a moment to initialize the interface. Before we click play on any code, we have to make sure our environment is correctly configured to use GPU acceleration. Go to the top menu bar, click on Runtime, and select Change Runtime Type. In the Hardware Accelerator dropdown, make sure T4 GPU is selected. Click Save to lock in the settings, and we are good to go. Now, scroll down to the first cell called Initialize System and Download Models, and click the play button next to the code block. Because we are borrowing a virtual machine from Google, it starts out as a totally blank slate. I wrote this automated script to lay the foundation for our project by installing essential tools like ARIA2C, SOX, and FFmpeg. I also programmed it to install necessary Python dependencies, including Faster Whisper and Deep Translator. Finally, it reaches out to GitHub to clone the official LongCat-AudioDiT repository. This step will take 3 minutes at most, so just let it run until you see a bright green banner at the bottom that says System Ready. Now we are ready to start making our voice generations. Let us begin with Mode 1, which is text-to-speech, or zero-shot voice cloning. Zero-shot simply means the AI does not require hours of your voice data to train a custom model. In the text box labeled Text-to-Speak, type out whatever you want the AI to say. Once your text is ready, click the play button for Mode 1. Immediately, a prompt will appear asking you to upload your target voice. This is the reference audio style you want to clone. Choose a clean, clear voice sample from your computer. A quick tip for getting the best results. Ensure your reference audio has absolutely no background music, no echo, and is ideally around 3 to 5 seconds long. If it is too long, the script is designed to automatically trim it to the first 5 seconds to prevent memory overflow. Once uploaded, the system first uses Whisper to transcribe your reference audio so it knows exactly what words are being spoken in the sample. Then, the diffusion transformer kicks in, analyzing the pitch, tone, and cadence of the reference voice, and synthesizes your typed text to match that exact style. When the matrix logs finish running, a success message will appear alongside an audio player. If we play our reference audio and then our cloned result, the similarity is striking.
Welcome to the team! Honestly, we have been counting down the days until you got here. Testing the zero-shot text-to-speech pipeline. If you can hear this in my exact voice, the 5-second prompt extraction was successful.
LongCat is very rigid and critically driven by the quality of your reference audio, but with a great sample, it absolutely rivals autoregressive models like Qwen3 TTS. We are using the 1 billion parameter model in this tutorial, but all in all, the clarity and accuracy here are truly remarkable. Next up, let us explore Mode 2, which is voice-to-voice cloning. This is distinctly different from text-to-speech. Instead of typing text, you provide a source audio file that dictates the words, the emotional delivery, and the timing, and you provide a target audio file that dictates the vocal tone. Essentially, you are acting as the voice actor, and the AI is reskinning your voice to sound like someone else while keeping your exact performance. Click the play button on Mode 2. You will be prompted twice. First, upload the target style voice, which is the voice you want to sound like. Second, upload the input content voice, which is the recording of you speaking the lines. Once both files are uploaded, the AI gets to work. It analyzes the content source by transcribing it to text and extracts the exact length in characters. Then, it analyzes the target prosody, which is the rhythm and sound of the style voice. Because audio generation is incredibly demanding on the GPU, the script smartly splits your input speech into smaller chunks based on sentence punctuation. It processes these segments one by one, restyling the audio in chunks to prevent Colab from running out of memory. Once all the segments are converted, it stitches them back together perfectly. When the conversion complete banner pops up, hit play. You will hear the original performance.
Days until you got here. I've looked over your portfolio, and I am just so thrilled about the fresh perspective you're going to bring to our upcoming projects. We're a really collaborative bunch, so don't be afraid to jump right in. We want to hear your ideas. Let's get you settled in. I just know we're going to
Getting a ton of comments asking, how do you actually get those really crisp cinematic shots?
spending 5 hours tweaking settings. And honestly, okay, that was doing it wrong for a long time.
The pauses and the emotion, but completely transformed into the target speaker's voice. Now, in my example here, the result missed our expectations because the model did not accurately process the input, dropping more than half of the pronunciation. This usually boils down to a tricky reference file. If you encounter this, just change the reference audio file, and your result will be okay. Now, let us move to something incredibly useful for global content creators, Mode 3, Cross-Lingual dubbing. Imagine you have recorded an English video, but you want to release it to a Chinese-speaking audience using your own voice. Make sure the target language dropdown is set to Chinese, and hit the play button on Mode 3. The system will ask you to upload the source audio file. Select your English audio clip. The workflow here is a beautiful combination of different AI technologies working in sequence. First, the Whisper model listens to your English audio and transcribes it into perfect English text. Next, that text is passed through a deep neural translator to convert the English script into grammatically correct Chinese. Finally, it takes that translated Chinese script and feeds it into the LongCat synthesizer, using your original uploaded audio as the zero-shot voice reference. It forces the AI to speak the new Chinese text, but utilizing the vocal cords, pitch, and timbre of the English speaker. As you watch the terminal output, you will see it extracting the source text, translating it, and synthesizing the dub. When it finishes, you can play the audio. You will hear the original speaker flawlessly delivering the lines in Chinese, maintaining their unique vocal identity across language barriers.
您如何真正获得这些？例如那些非常清晰的电影镜头，而无需花费5个小时调整设置。老实说，好吧，这么长时间以来都做错了。
I do not understand Chinese myself, so please let me know in the comments how accurate the dub sounds if you do. Finally, we arrive at the most complex and impressive feature of this notebook, Mode 4, the multi-speaker podcast generator. The base model originally supports multi-speaker capabilities, but I have created my own version of that feature in a different format. Look at the script input box. You will notice the text is formatted as a dialogue, labeled with a colon for speaker A and B colon for speaker B. The script uses regular expression parsing to read this block of text and separate it into individual lines assigned to different virtual microphones. You can write your own custom script in a notepad document, making sure to stick to that exact A colon and B colon format, and then copy and paste it into the script box. Alternatively, just feed a language model with the sample text in the notebook, and it will adjust any of your dialogue to match our style perfectly. Now, click the play button for Mode 4. You will be prompted to upload 2 separate files. First, upload the host voice, which will be assigned to speaker A. Then, a second prompt will ask you to upload the guest voice, assigned to speaker B. As mentioned in the notebook documentation, it is critical to use short reference audio clips for this, as long clips might cause the AI to hallucinate or blend the voices together. Once both files are uploaded, the script extracts the acoustic prompts for both speakers simultaneously. Then, it begins the rendering loop. It looks at the first line of the script, sees it belongs to speaker A, loads their voice profile, and generates the audio. Then, it sees the next line belongs to speaker B, swaps out the voice profile in the GPU memory, and generates the response. It does this back and forth, rendering turn after turn. A massive optimization happening here is that it streams these chunks directly to the disk as they finish. This clears up the VRAM, allowing you to generate incredibly long podcast episodes without crashing the free Colab server, though it does come at the expense of a bit of processing time. The script even automatically injects natural fraction of a second pauses between the speakers so it does not sound like they are unnaturally cutting each other off. You can watch the progress output as it loads weights and processes each turn. When the purple podcast production complete banner appears, you have successfully generated a multi-speaker conversation. Hit play on the output file.
Welcome to the sound check. Are we recording?
Yes, levels, look good on my end. How is the new setup?
It's fantastic. I'm testing the multi-speaker generation with our new regs parser.
That's a huge upgrade. The audio should flow much more naturally now.
Exactly. If this chunk renders correctly, it means the script is properly switching voices without hallucinating.
It is a fantastic tool for creating audiobooks, automated interviews, or video essays. You can download your audio results by simply clicking on the three-dot button and saving them right to your storage. When you are completely finished experimenting, downloading your audio, and using the notebook, go to the top right corner where your RAM and disk usage is displayed, click the drop-down arrow and select Disconnect and Delete Runtime. You can download the community version of this notebook on my Patreon for free, and the Pro version is available for my Patreon supporters. Take the time to experiment with different voices, tweak your scripts, and push the boundaries of what these diffusion models can create. See you in the next tutorial. Peace.